Welcome back to Friday Night Mathematics, Year 10s. We are going to do the rules for congruent triangles. That's our topic for today. Now, what does congruent triangles mean? Congruent means the same. So, these are tests to determine if two triangles are the same. There are 4 tests. They are SSS, SAS, AAS, and RHS. So I'm going to rip through these rules. Do you want to have a guess what SSS stands for? Side, side, side. It essentially states that if two triangles have the same sides, all 3 sides are the same, they're the same triangle. Next one, want to have a guess what SAS stands for? Side, angle, side. Now, importantly with this rule, the angle does have to be between the 2 sides, right? So angle must be between the 2 sides. That's why you always see that particular rule written as SAS rather than something else. You don't see it written as SSA, do you? And that's because the angle does have to be between the 2 sides. So there's a bit of a quirk with that. You've got to be careful. This one here, want to have a guess what that stands for? Angle, angle, side. So if 2 triangles have 2 angles, corresponding angles and a side in common, they're the same triangle, they're congruent. And last rule is right angle, R for right angle, H for hypotenuse, and S for side. So if 2 triangles, they both have a right angle, you have the hypotenuse for both, and you have another side for both, you can say they are congruent under the rule RHS. Now, rather than do all that in huge, ridiculous detail, what I'm going to do is I am going to show you how we use these rules by examples. What's possibly new for you is we're going to use a lot more symbols in how we explain and prove these rules. And that's where the challenge is. It's not in remembering the rules, though you should, and you will need to. The challenge is in the proofs that we're about to do. So I'm going to pause for a second, come back. All right, so our challenge with these triangles here is to prove they are congruent, if they are indeed congruent. And I'm just going to put a few more labels on them, D, E, F. I might make this S, T, U, S, T, X, Y, Z. There we go. So we're now going to use a rather formal process to prove that triangles are congruent. And yes, this is how you will have to do this. So what we do is we state what's in common. Now you see here, this right angle, they both have a right angle. So I can write angle BAC equals angle EDF. Notice how my selection of letters here describes where the angle is. If I read out BAC, think of drawing a line BAC, it can only describe that angle there, can't it? That's why I write it that way. I could have also written it CAB, technically. If you want to be really technical, I could have written it CAB as well, but I've chosen the earlier letter in the alphabet. So they have that angle in common. And it also happens to be a right angle. That might affect what rule we call this under a bit later. Right? So what else do they have in common? They have this side in common, the hypotenuse. the hypotenuse is always opposite the right angle, if you look closely. So anyway, the side BC on here is the same as the side EF over here. So they have a side. And they also happen to have a third side in common here. Side AB is the same as DE. Now this is an interesting one. You can see that they have an angle and two sides in common, and you might be tempted to go SAS, but it's actually not SAS, because to use SAS, the angle would need to be between the two sides, and that's not actually the case. We don't have that side there. To use SAS, I'd need to have the value there. But we do have RHS, right? We have a right angle, we have the hypotenuse, and we have another side. So we can write triangle ABC is congruent. That symbol means is congruent to angle, and I'm going to make to triangle, and I'm going to make sure I use the equivalent sides. A is the equivalent of D. B is where the 7 and 16 join. It's the equivalent of E. And F is the last side there. So, and we always say which rule we're using. So triangle ABC is congruent to triangle DEF by the rule RHS. So there we go. That means is congruent. It's just an equal sign with an extra equals in it. So we're going to do the same trick to the second one here. What do they got in common? Straight away I can see that 70-degree angles in common. So angle SUT is equal to angle XZY. So they have an angle in common. They have a side in common here. Now, by the way, triangles are still congruent if they've been flipped. If you look at those two pictures for a long time, you realise that not only are they turned around, I think you'll find they're flipped. It's actually been flipped. Still congruent if you meet the rules. So side TU there, this one here, 12 centimetres, matches YZ. So there's a side. And also side SU here matches with XZ. So we have an angle and two sides. This time we can use SAS because the angle is between the two sides in each case. So this time, when I write it, I'm going to do triangle STU is congruent to triangle. Now I've got to get the equivalent. So the S is where the 7.9 ends, so it's X. T is where the 12 ends, it's the equivalent of a Y, leaving Z. So triangle STU is congruent to triangle XYZ by the rule SAS, side, angle, side. So that's two examples of how you are meant to show congruency. I'm going to give one more weird example, and that will be it for today. All right, last bit for tonight. Are these two triangles, this one and this one, congruent? Well, let's see what we've got. First off, you're probably good putting some labels on it. Right? If you're going to do these formal proofs, you need to put labels on it. If the labels aren't there, you need to put them on. Label it if needed. So, what do you call it? A, B, C, and D. Okay, straight away from the markings here, what does that marking mean? It means those sides are the same. So AC is equal to AB. That's a side in common. These two, their markings there, so those are the same. So CD is equal to BD. You've got another side in common. And that side there, well, it's shared, isn't it? The side AD is shared. So you've got a third side. You also have an angle in common there if you wanted to. ADC, that right angle, they've both got a right angle there, is equal to angle ADB. In cases like this, sometimes you can make multiple rules fit. To start with, I'd say that, look, 3 sides together, straight away that gives us SSS. So I can write that triangle ACD is congruent to triangle ABD by the rule SSS. And you know what? I could also use other rules. Because they had the side angle side where the angle's between the two, you could have also used SAS to argue it. You've got the right angle, you've got the hypotenuse and another side in common as well. You could have also used RHS. What does that leave? That only leaves AAS, which you couldn't use because you don't have 2 angles. So look, some of these questions end up being flexible. It's just a matter of really pinpointing everything they have in common and going from there. So that's it for today. Your rules for congruent triangles, SSS, SAS, AAS and RHS. Apply them, use the symbols, show the formal proof. Have fun.